Welcome back to Advent of Code 2017, day 14, disk defragmentation. Suddenly a schedule job activates the system disk defragmenter. Where the situation different, you might sit and watch it for a while, but today you just don't have that kind of time. It's soaking up valuable system resources that you need elsewhere. So the only option is to help it finish its task as soon as possible. The disk in question consists of 128 128 grid. Each square of the grid is either free or used. On this disk, the state of the grid is tracked by the bits in a sequence of NOT hashes. Okay. The day 10 stuff. A total of 128 NOT hashes are calculated, each corresponding to a single row in the grid. Each hash 128 bits, which correspond to individual grid squares. Each hash contains 128 bits. Each bit of a hash indicates whether the square is free or used. The hash inputs are a key string, your puzzle input, a dash, a number from 0 to 127 corresponding to the row. For example, if your key string were this, in the first row would be given by the bits of the NOT hash of this minus 0. Second row from the bits of this minus 1, and so on. The output of a NOT hash is traditionally represented as 32 hexadecimal digits. Each of these digits will correspond to 4 bits, or a total of 128 bits. To convert to bits, turn each hexadecimal digit to its equivalent binary value. High bit first. 0 becomes 000, 1 becomes 001. Okay. Hash that begins like this is this. Continuing this process, the first 8 rows and columns for key FL blah blah appears as follows using hashtag to denote used squares and dot to denote free ones. 8108 squares are used across the 128 by 128 grid in this example. Given the key string, how many squares are used given this puzzle input? Okay, maybe we can try this. This one. So I have an input. Then I go 0 to 127. I have the rows is this. Input, or maybe like this. Minus, and then it. So it's like this. These are the inputs, and it is NOT hash, which I think I saved. Yeah, here. Okay, how do I? Let's get this all out here. That was a lot of work, this not hash stuff. Then we get not hash. Yeah, so the input. Is it again with 255 then? Yeah, here we did the first one part and then we did this, and then we got the hashes, so it must be this part. So I just run the whole code. The length is kind of what my input is. So string length. Then just get rid of that. No, I need part of it. I need the part that splits it. Key. Let's say key is this key. I know for run 2 we need the line, right? So that is just the key. And we just ignore part 1, I think. We need input anyway. Okay. Part 2 is just this is string, yeah. Now I can not hash each row. Yeah, these guys, and then need to see how to get them to bits now. So every 2 or every number Every digit in the 32 length hexadecimal digit string corresponds to 4 bits. And for each not hash, let's get an example maybe. This one. I need to go like for each character. Hmm. How do I get a bit? Like if I have a number, hmm, need to check it. I wonder what 2 byte does. Hmm, I think that's Java, is it? If you have like string, oh, let's print that. Char A is not a decimal digit. It's kind of like a hexadecimal digit, right? Confused. Didn't I also have it already, kind of? Let's check again what we do here. So I have an it here. 2 hex string. Okay, maybe I need to just convert hex to number. Hex to int. And then I have an int, and I can do the binary string. How does that work? Hmm. I wonder what hex to byte does. Hmm. One, zero, 1, 0. Yes, it's the beginning, and then 0, 0, 0, 0. So I need now. I have some arcs here. Hmm. There's no padding. Let's hack it together real quick. Um, Binary string. Okay. We do this. Left pad. Then then we just have to join the string again, right? Let's see. Oh wait, I have to do this. Okay, we got the 4 zeros. Then we have 1, 1, 0, 0, 0, 1, 0, 0, many zeros, and then 1, 0, 1, 1. This is working. So for each NOT hash, we do this. This everything. Oh, now I want to see it. And I think that's my grid, right? So if what's a 1 and what's a 0? Okay, 0 is free and 1 is used. And what I want how many squares are used. How many ones are there? So then I can just go like this. And I have 8, 1, 0, 8. That's this. Cool, and then I can change the input. We have 8, 0, 7, 4. And we're there. Part 2. Now all the defragmenter needs to know is the number of regions. A region is a group of used squares that are all adjacent, not including diagonals. Every used square is in exactly one region. Lone used squares form their own isolated regions, while several adjacent squares all count as a single region. In the example above, the following 9 regions are visible, each marked with a distinct digit. Of particular interest is the region marked 8. While it does not appear contiguous, in this small view, all of the squares marked 8 are connected when considering the whole 1, 2, 8 grid. In total, in this example, 1, 2, 4, 2 regions are present. How many regions are present? Okay, so this is a region, and this is a region. So no diagonals allowed. So we have to we have a grid now. We have it. Let's check again. Okay, it's not slow. Now we find groups. So we can just go through the whole field basically, right? And for each point, if it's a 1, we just find the groups. If it's 0, we don't do anything. And then we check how many distinct groups there are. I do something like each row, for each row, for each y, we can check x and y, find groups, and group for this coordinate. And the group is like a set of coordinates. And then I add that to my list of groups. of set of points and group takes if it's a 1, then we look for groups based on this point. There's a list of string, and we return a set of points. So we go in all the directions, just to have here, which is into y and x into either direction. For each direction, I check if um, like a field, right? And I can use the rest here. Okay, it's still confusing. Let's just use group list of points. I think I could just search here then again though. Let's say visited is list of points, current is list of points. While not done. Next is visit find next of current and visited. Next is empty, I'm done. Current is next. Return group. So then I have another function. Current list of points. Visited. List of points. I return a list of points. And then I go. I also have to put the field in here actually. Now I have a result, virtual list of points. And then I go correlate for each that I want to visit. The result for each there. I go, that work? If I get a 1, then I add it. And then That's what I return. That's all the fields that I can visit in this round. Mhm. Maybe you don't want to go in circles. Then I can update this type. It should be a set, I think. And I can change here to set. Neighbor. Let me just end. Okay. Then current is a mutable list of P. I don't know if it has to be mutable. I find a group which is some kind of set of points. Then I can add that group to my groups. And then I say size of this array is the answer. I think that's it. Let's run it. Work. Obviously, we can't go in all directions. Great. Then what's going on? And index. Then we can do this. Must be happening here. Oh, and stupid field.lassen. N.y, of course. Okay, now I have a result. I'm not printing it. Oh, wait. What? Hmm. Here's the group. Oh, and I want groups dot. Maybe you want to check. Oh, filter it size. So I don't want an empty group like this. Okay, 6, 4, 3. Let's see if that makes sense. Too low. How many regions? Okay, I need to also add it. Too low. Weird. I do like, wait, can I sort by and then but a group only has points. Why do I need comparing 2 points? X, Y. Like this. Oh, I don't know how to build it always. Sorted by. Yeah. So it by just has 1 point. P dot X times 1000 plus P dot Y or something like that. Is that not a comparator? Set again. I mean, probably I can do it here then. I feel like we'll be, oh, it's even the same. Maybe it's just with the empty group, doesn't really make sense. Can I do this guy? 1200 regions are present. I look at the first ones, maybe I can see something. The first also I can see it here, right? Here's 1, 1, 1. See that region. 0, 0, 1, 1, 1. Nice. I have that also that number. So I have 0, 3, 1, 3. Which is this one. So I'm finding those. 0, 5, 1, 5. That's one, yeah. Oh, yeah. Oh, you know what? I didn't add. This is basically cur. List, immutable set. Yeah, I forgot to add the individual ones. And I get 1242 here. Yeah. So now I change the input. 12, 12. Okay, that's it. So let's talk through it. 14. We want to count these squares that are output from this hash function. So each line is an output from the hash function. And then it's basically either when you present it in binary, it's 1 or 0, and the 1 is what we want to count. So these are hashtags. How many of those are there? How to do that? We just apply this not hash on day 10. Then we do integer to binary string for the after representing each hexadecimal string as an integer. So we go from hexadecimal string to integer to binary. And then we have the binary string. And then we check that each part of the string has 0 in front, so that every binary string part is length 4 exactly. So we like left pad it with 0, and then we join that to that output, which is this output then, ones and zeros, and then we can just go where we can print it. Then we see, oh, what's going on here now? No, I went too far. Where is it? Here. We see these ones and zeros. So we can say, okay, let's just count each row, how many ones there are by summing up the row. And then we sum up the result of that, and then we get the sum of the rows for how many squares there are. And then in part 2, we're interested in the number of regions, not including diagonals. So basically we walk between all those ones or hashtags, and that's a group. So this is one group, everything that I can reach adjacently but not diagonally is within the same group. So this is one group, this is one group. The 5 is a one group for itself. The 6 is one group for itself. The 4. Then I can count how many of those regions there are. So what we do is we just go through each coordinate in the grid. So let's say here, this one. Check if it's a 1. If it's a 0, we don't do anything because it's not interesting for us. If it's a 1, then we walk into all directions, classic breadth first search, find a group where we can then run the breadth first search here for each current thing in our list. We can find the neighbors in the directions, which is, are they on the grid? That's this. Is it on the grid? And then if it's not visited yet and it is a 1, then we can add it into our group. And then once we walked in all directions and found everything, that's our group. So we added all those here, and then we add that into our groups, which is the visited, which is a set of points. And then actually, I don't know if we need to sort it. I think I was sorting it so that the sets can be compared, but I guess, yeah, sets are the same because they are not sorted anyway. So the same answer would come out like this. Let's run it again. So once we found, so yeah, the same answer comes. Once we found all the groups, that's what we're interested in. So I just printed them. But what I'm interested in is the size of the groups. I was also considering filtering out the empty group, but the empty group doesn't exist because we always include ourselves into like the starting point into a group. So a group is always at least size 1. So we just have groups.size, and that's the answer for part 2. Enjoy the rest of your day.